Continuation of the last problem, we have our roller coaster now at the peak of its path, and it's going to begin its descent down the track into the bottom location. And we're looking at what happens, what transitions happen as it goes from the top to the very bottom of the ride. Now, question A asks about the bottom of the ride. Since we're back down to the original level, what can we say about the potential energy? Well, potential energy is mass times gravity times vertical height. And since the height is 0 at the bottom, that means my final potential energy at the bottom is also 0. So it has no potential energy at the bottom of the ride. Question B, assuming there's no losses, so no losses to heat or sound or anything like that, what must be the kinetic energy at the bottom? Well, we know energy has to be conserved. So the total energy before, at the top of the ride, in other words, has to equal the total energy after, at the bottom of the ride. And we've already established at the top, it's all potential. That's my initial energy, 400,000 joules. And at the bottom, it's all kinetic. All that potential energy got transformed into kinetic. There was no potential. So if my initial potential energy was 400,000 joules, that would all get converted to kinetic energy at the bottom of the ride, since it doesn't have to share it with any other energies. Question C, if the actual kinetic energy turned out to only be 240,000 joules, what is the efficiency of the roller coaster? Well, efficiency is useful output energy divided by my input energy. And if we want to get percentage, we multiply it by 100%. Well, the purpose of this first drop is to take its potential energy and convert it to kinetic. So my useful output energy was all that kinetic energy at the bottom. That's what we want it to be. My energy started as potential. So it's like a test score. How much of that potential got converted to kinetic? So I put the numbers in. My final kinetic energy was 240,000. My initial potential was 400,000 times 100%. And that ends up being 60% efficient. So 60% of my initial potential energy got converted into useful kinetic energy. Now, where would this wasted energy have gone? This is question D. Well, you can imagine as this roller coaster is traveling down the track, it's vibrating, creating a lot of unwanted kinetic energy, right? That's not in the linear sense. That's just vibrational kinetic energy. That in turn is creating sound, and there's friction on the track, so we're generating heat. So all of that energy, E heat, E sound, all that vibrational energy, etc., is all being wasted. And that's where that missing energy would have gone.